We just did something where we used, I'm going to pretend it's string. We couldn't find string and had to use masking tape. But let's pretend we had string and measured the width of someone's arm. How many of those widths through the middle of the arm would it take to go around? 1, 2, 3, and a little bit more when we actually did this on people's arms. Or if we went ear to ear, how wide is your head? How many of those widths from ear to ear does it take to go around your head and make a headband? It was 1, 2, 3, and a little bit more. And heads and arms aren't circular. If we did this with real circles, it doesn't matter how big they are. The answer is more than 3 and less than 4, and it would always be the same number. And so we call it pi with that fancy symbol. And this formula doesn't mean anything magic. It is not like, Pythagoras went up to Mount Sinai and got some fancy formula. All it means is that if I take the width of a circle, the diameter, and wrap it around the outside that many times, that's all the way around. It's more than 3, it's less than 4. Yeah, circumference is pi times diameter. You can think of it as perimeter is pi times the width. That makes more sense to you. So it's not some magic thing. It's not like we derived this. It's just whatever the answer would be, we call pi. There had to be some number, which is how many widths of a circle go all the way around it. More than 3, less than 4, we call that pi. So if we had a circle, and all the way across, let's pick a number.
So you have a circle without a stable.
So we have 3s on the board already. Pick a number other than 3 and 4.
6.
6. So this is 6 inches wide. So what's the distance all the way around the circle?
6 times
6 times pi. So 6 times pi. We go to our calculator. 6 times, whoops, clear. 6 times pi is about 18.8. And I should use my squigglies equal sign. That means I'm rounding. And we are in inches. So that's all that it is. It's some number a little bigger than 3. 6 times 3 is 18. This is a little more than 18. And when you wrap it all the way around that many times, you finish going around the circle. Sure.
3.14.
It's about 3.14. It goes on and on. You can always take your calculator and say, hey, calculator, what is 1 times pi? And it tells it to you as much as it is. It doesn't actually ever stop repeating. It's one of these fancy decimals that never has a pattern. But basically it's more than 3 and less than 4, right? It's about 3.14. And remembering to not round in the middle of problems, if you had a problem where the numbers they measured and gave to you in the word problem had thousands, then you would want to use pi to thousands. So you're as accurate as the measurement you had. And if you were someone in the pharmacy measuring very carefully, you wouldn't want to use pi that's only 3.14 if there were more digits being measured for you. Yeah, so use as many digits as they give you. And for most things in life, we measure things about to 1 or 2 decimal places. So 3.14 is a fine thing to memorize. But your calculator will have a pi button, so it will just know it to as many decimal places as you would ever need. Okay, now we're going to do something that's a little more interesting and complicated. Look at this little brown square. Each side I'm labeling R. You don't know why yet, but for now it is just an R. So what is the area of this? R times R, which I'm calling R squared. If you haven't seen the exponent, because you weren't here that day, then all that exponent of 2 means is that I'm multiplying R by itself. which I'm doing, because that's the area for a square rectangle, r times r. So r squared is just r times r. Now I'm going to photocopy this and have 4 of them. So each of them is r squared. Everyone okay? Yeah, so this is 4 r squareds. If I ask the question, how big a circle can I fit on this big brown box of 4 r squareds? Well, it looks like it's more than 3/4 covered, but there is some sticking out. These little kind of wing-shaped things in the corners. So it doesn't cover all 4. Again, the answer of how much the circle covers of the 4 r squareds box, it's more than 3/4 of it, more than 3 of the r squareds, but it doesn't cover these little corners, so it doesn't cover all 4. Bigger than 3, less than 4 of how many r squareds it covers. By the way, the reason I picked r was so that this line of from the middle to the edge of a circle, I could label as r. Because we're about to say that's radius, half of the width, half of the diameter is the radius, another word you should memorize. So the magic is that the answer to this question is the same as when we put string around people's heads. How many of those 4 r squared boxes does it cover? More than 3, less than 4. It turns out to also be pi. And there's no reason at the amount of math you know why it would be the same. Why isn't it 3.4 instead of 3.14159? But just trust that it is the same, and that's nice because that means on our calculator we only need 1 button, whether we're doing circles with perimeter or circles with area. So if I take a circle, let's use the one we had before that was 6. So here's that circle we had a moment ago that was 6, what was it, inches?
Yeah.
It was inches, okay. So it's 6 inches wide, 6 inches in diameter. So that means if all I care about is the radius, how long is the radius? 3 inches, half of the 6. Everyone with me so far? So if I say r squared, radius squared is this box. R times r equals r squared. How many of these boxes does the circle cover? More than 3, but less than 4. Right. By the way, how big is this box? 3 times 3 is going to be 9 square inches of area, right? So the area of the whole circle is pi times that r squared box. 3 times 3 is 9, which is about, let's figure this out. About 28.3. We missed it. We did a 3 times 3 equals 9. Oh, okay. This one has a radius of 2 inches. If we want to find the area and the perimeter of it, we're going to need both the radius and the diameter. So what's the diameter of this one? 4. Okay, so perimeter is pi times which thing? Pi times the diameter. So pi times that 4, which is about however much 4 pi's are. 12.6. Is this inches or square inches? Just plain inches. We're walking around the outside like an ant, so it's just plain inches. The area, if I make the R squared box, what's the area of this box? 4, right? So it's going to be pi times that. Pi times the R squared. So pi times that 4 square inches. And whatever that is, it's about 12.5. Oh, same thing. The numbers are the same on this problem, but they mean very different things. One is that it takes a little more than a ruler, 12 inches, to go around the outside. And the other is if you gave me 12 tiles that were little squares, 1 inch on the side, it would take me a little more than 12 of them to cover the floor. I'd have to like break them apart to make round edges, but still, with the crumbs, it would take a little more than 12. Okay, how about the circle on this side? So the perimeter is pi times the diameter, that width. If the dots for multiply are confusing you, just let me know and I will go back to always using the X's. So what's the diameter this time? 2. So pi times 2 is about 6.3. And we are still in the world of inches. Why are they plain inches and not square inches? Yeah, the perimeter is the ant walking around the edge. It's just a distance it goes. For the area, what's the radius now of our 1 inch? So let me draw it this way. So if I drew a box, what is my radius squared box now? 1. That is the definition of 1 square inch, a box an inch on a side. That's as 1 square inchy as we can get. So the area is pi times that R squared box. So that's going to be about 3.14. Oh, they say 3.1 square inches. Everyone okay with these examples? You could do this as homework. Do you have to draw the little boxes for the R squareds? No, you could just multiply 2 by itself. You could just multiply 1 by itself. But it's nice to see the picture of what's happening. How many of these boxes does it take to make up the whole circle? A little more than 3 of them. Okay, I think we're done, so I'm going to stop.